Alright, so welcome back to another video. Today is another episode and we are going to look at how we can tackle problems on integration by substitution. Of course, we have types or techniques of integration, but then we will begin with integration by substitution. Of course, we have by part, we have by partial fraction, we have by reduction formula, but we will begin with by substitution. Later along the line, I'll add up the rest as well, right? So, but before I begin, let me wish you Merry Christmas in advance. Enjoy with care, and as you enjoy, then you enjoy with my content as well. All right, so we have integration by substitution. All right, so what we can use integration by substitution to do is only applicable in integration where when you have an integration question and you apply this substitution, normally we use the u substitution, and you substitute u into the integrand, right? And you don't have any variable apart from u, then you can do what we call substitution or integration by substitution. But when you apply the substitution, right, and you still have another variable apart from the u, then you can't go ahead and apply the integration by substitution, right? So let's begin with this particular problem as problem number one. So problem number one, we want to find the integral of x over x minus 6 dx, right? So this problem right here, we can apply the integration by substitution. So let's go. Let u equals x minus 6 right here. So this right here, we can rewrite it as x equals u plus 6. Of course, when you bring this here, then you have x equals u plus 6. So this right here, we are going to substitute u in place of x minus 6 and x in place of u plus 6, right? So we have here u plus 6 all over, now x minus 6 is u right here, right? Now the x, right? We have the x, we have changed everything from x, so we have to change the du, the dx to du, right? So we have here, right here, we can split this and have 6 over u du, right? So this right here, we can have 1 plus 6 on u du, right? So this right here, when you integrate 1 with respect to u, it means you are going to have u plus integrate 6 over u, you are going to have 6 ln u, right? The ln should carry only positive numbers, right? You forget to make it raw or you make it opened, it means that it's going to carry negative, but you don't forget that ln doesn't accept negative value. It takes numbers above 0, right? So this right here plus a constant of integration c, but we said that u should be what? X minus 6. So we have right here u, which is x minus 6 plus 6 ln into x minus 6 plus c, right? So we can say that minus 6 and c, they are constant. So we can say that x plus 6 ln x minus 6 plus c minus 6. This right here as one term, so we can represent this as, so let c minus 6 equals what? K, right? So we have x plus 6 split into x minus 6 plus k as our final answer. So this is the integral for this particular problem right here. Let's look at problem 2, right? Our problem 2, which is the integral of sec squared a all over integral of 1 over 4 plus s squared dx. Want to look at how we can tackle this as well. So this right here, we have to do what we call substitution. So let's x equals 2 tan a, right? So if s is 2 tan a, then we can do that substitution right here. So we can say that integral of 1 over 4 plus 2 tan a all squared, right? Dx. But so far as we have changed the x to a, then we mean that we have to avoid this the x right here. So let's differentiate this, right? So when we do that, differentiation, that means we have the x equals 2 sec squared a dA. Don't forget the differential of tan a is sec squared a, right? So this right here, we are going to replace the dx with 2 sec squared a, right? So we have right here 1 over 4 plus 2, right? This right is going to be 4 tan a tan squared a. Then our dx now is 2 sec squared a dA, right? So we have right here 2 sec squared a dA all over 4 plus 4 tan squared a, right? So now, this right here, we can do what we call factorization. So when we do that, then we are going to have 2 sec squared a all over 4 into 1 plus tan squared a dA, right? So right here we can have so right here we can have 2 sec squared a all over 4 into 1 plus tan squared a dA, right? But of course we know that 1 plus tan squared a is sec squared a. So we have, but sec squared a is equal to 1 plus tan squared a. So we can do this substitution in place of this. So we have 2 sec squared a all over 4 into sec squared a dA, right here. But we know that we can factorize this constant out. So when we do that, and of course this can cancel this. So we have 2 over 4 integral of 1 dA, right? So when you integrate this one right here, we are going to have 2 over 4 into integrating 1 with respect to a, we have a plus a constant of integration. But this can be broken down to half into a plus constant of integration. But earlier on, we said that s should be equal to 2 tan a, right? So if that is true, then we can say that if s is equal to 2 tan a, then we can make A the subject and come and substitute right here. So we have right here over 2 over 2. So this takes off this, and we have tan A is equal to x on 2, right? So we can make A the subject here. So we make A the subject, we are going to have tan inverse of x on 2. So that is A right here. So we substitute this into this. So we have half into tan inverse of x on 2 plus c. So that is it for this particular problem. So this is the solution to this particular problem. Half tan inverse of x on 2 plus c, right? This is the problem, the solution to this particular problem. You have to go through step by step to understand this concept. It's so easy to get it done, right? So let's move on to the next problem on integration by substitution. So our next problem is going to be integral of sine squared x dx, right? So we want to integrate sine squared x dx, but we don't forget that there is an identity for this, right? But we know that sine squared x is equal to 1 minus cos squared x, or sine squared x is equal to 1 minus 2 1 minus cos 2x on 2. This is an identity, this is also an identity, but we can't use this right here because this square, we can't differentiate it so easy. We can't integrate it so easy like that. So we have to consider 1 minus cos 2x over 2 in place of this. So we have here 1 minus cos 2x all on 2 dx, right? So we can now integrate this. We can decide to bring the half out, so we can have 1 on 2 integral of 1 minus cos 2x dx, right? So we can integrate this separately. So when we integrate 1 minus cos 2x dx separately, then it means that we are integrating 1 with respect to x. So when we do that, then we are going to have, let's do the separation. So separation integral of 1 dx minus integral of cos 2x dx, right? So we integrate this, then we combine it, right? So let's integrate 1 with respect to x. So when we do that, we have x right here, right? And also, let's integrate cos 2x dx. Right? Cos 2x dx, if you want to integrate, then we have to do what we call the substitution or the u substitution. So this part, we are going to have integral of cos 2x dx, right? So in integrating cos 2x, let's cos 2x equals u, right? So or of course we can let our u equals 2x first. To make the work easier, let u equals cos 2x, because when you do that, it means that we are going to have cos u du, the x instead, right? So we integrate this, then we differentiate this, we add it, right? So we have here du is equal to 2 dx, right? So we make the s the subject, we are going to have du on 2, right? So this right here, you know that when you integrate cos, right, you are going to have sine u um sine u plus c, right? So that is it for this particular integration, right? So right here we know that we have our u to be what? 2x, right? Our u is 2x. So when we do that substitution, then we are going to have right here as sine into 2x. Then of course, when we integrated the 2x, we had half the u, right? So that is it for this particular one. So we are going to have half sine 2x, right? So that is it for this integrand, the integral of cos 2x dx, right? So we cannot substitute this in place of this. So we have here half into x minus sine 2x on 2, right? So we expand this, now we have half x minus sine 2x all on 4. So this is our final answer to this particular problem right here. So this right here, we're going to have 1 on 2x minus sine 2x on 4 as our final answer. That is it. It's very simple. You just have to follow proceedings, and then you get it done so easily, right? So let's look at the next problem on integration by substitution. Integrating by substitution. So the next problem is going to be integral of sine square root of x all on square root of x as well, right? So this right here, when you want to integrate this straight away, you are going to find yourself in problems, right? So you just have to do substitution and you're good to go. So right here, let square root of x equals u. Of course, we can say that u squared is equal to x. Nothing changed because we just square both sides to have u squared equals x. So right here we have 2u, we are differentiating. So we have 2u du is equal to the x, right? So now we can do this substitution, right? Since we said u with x should be equal to u, so wherever we see with x, we put u there, and then the x, we put 2u du. That is it. So we have right here sine, of course, u all over u times the x now is 2u du, right? So we have right here this taking of this, and then we are going to have 2 sine u, that is integral of that du, right? And then we know that this constant can come out, so we have sine u du right here. So the integral of sine, we all know that the integral of sine is negative cos, right? So we do that and it's going to be simple for us. You know, integration by substitution is, of course, the simplest way of integration. That is why I started from that point before going up. So we know that the integral of sine is negative cos. So we have negative, of course, cos u plus c. And we said that our u should be what? Root of x. So we have negative cos square root of x plus c. So this is our answer to this particular problem. Very, very easy. So that is the fourth problem, of course. And let's look at the fifth problem. That is integral of x plus 4, s plus 4 power 5 dx. Right? So this is what we have right here. How do we integrate this? Let u equals x plus 4. Right? So when we do that, it means that our du is equal to dx. Right? So we now do this substitution. So we have this right here is u. So we have u power 5 du. Right? Now we can integrate this. So when you integrate u power 5, you know that you're going to have u power 6 all over 6 plus a constant of integration. And of course, you said that our u should be s plus 4. So we have s plus 4 power 6 all of 6 plus c. And this is the final answer to this particular problem. So easy, so easy. So let's move on to the sixth problem. So our sixth problem is going to be integral of cos into 3s plus 4 dx. Right, so how do we do this? This right here is another simple problem that we can have. Another simple problem you can ever have. Right here, we can say that we should let our u equals the inner function of the cos. So we have u equals 3x plus 4. So we can say that integral of cos u dx. But this way, when you differentiate them, you're going to have the u equals 3 dx. Right? So when you make the s the subject, then you have the x equals du on 3. Very simple. So we have here integral of cos u times the x now is du on 3, right? So we have 1 on 3 integral of cos u du. And of course, you know the integral of cos as usual as sine, sine u, right? So we are going to have right here as 1 over 3 sine u plus c. But earlier on, you said that u should be 3s plus 4. So when we do that substitution, then we're going to have 1 on 3 sine into 3s plus 4 plus c. And that is the solution to this particular problem. So easy, so easy. All right, so this is the sixth one. Let's look at the seventh problem, of course. Our seventh problem is integral of 1 on 1 minus 2x right here. Good. So this right here, we have to do what we call the u sub, right? So this right here, let our u equals 1 minus 2x right here. So when we differentiate this, we are going to have the u equals minus 2 dx, right? So the x is equal to 2u, of course, the u over 2, and that is negative. So we do this substitution, and we are going to have 1 over u, of course, negative du on 2. So we bring the negative half out, then we are going to have negative half integral of u, 1 on u du. And we know that the integral of 1 on u is ln u, right? So we have, of course, negative ln u plus c. But we said that our u should be 1 minus 2x. So we have negative half ln into 1 minus 2x plus c. And this becomes our final solution to the problem right here. Let's look at the 8th problem, of course. So our 8th problem is 2x square root of x 1 plus s squared dx, right? So how do we do this? This right here, we have to do the u sub. So let's we let whatever is under the square root sign equals u. So u equals 1 plus s squared, right? So differentiate this, du is equal to 2x dx. Very simple. So this right here, we are going to have our dx equals du on 2x. That's it. So we do the substitution, 2x square root of u. Now the x is du on 2x, right? So we can see clearly that this takes off this, and we have everything completely in terms of u, right? Now we can integrate square root of u du, and we know that we can change this to half, integral of u power half du. And we know that when you integrate u power half, you get u power 3 on 2 all over 3 on 2 plus c. But we can rewrite this as 2 on 3 u power 3 on 2 plus c, of course. And then we said that u should be what? 1 plus s squared. So we can say that we have 2 on 3 u power 3 on 2 plus c. But our u is 1 plus s squared. So we say that 2 on 3, 1 plus s squared power 3 on 2 plus c. So that is it for this particular problem, right? So easy. But you can rewrite this as under a square root sign, but it doesn't matter. You can leave it this way. So this is our 8th problem. Let's look at the 9th problem. The 9th problem is going to be integral of 4x all over square root of 2s squared plus 1 dx. So how do we integrate this particular problem right here? So what we have to do is that we have to let 2s squared plus 1 equals u. So when we do that, so we let u equals 2s squared plus 1. So when we do the differentiation on this, we're going to have 4x dx. So make the x the subject, then we're going to have du on 4x. Very simple. So here we can do our substitution. 4x all over square root of u. Of course, we said that 2x squared plus 1 should be u, times the x now is the u on 4x, right? So this clearly takes of this, and we have 1 on the square root of u du. Of course, we can rewrite this as integral of 1 over u power half du. But u power half, when you integrate it, of course, you can rewrite this as integral of u power negative half du, of course, so that our integration won't be so much tough for us. So this right here, when you integrate this, it means that you are going to add 1 to this, right? And when you add 1 to negative half, that means that you are going to have positive half, right? So you have this right here as u power positive half, because negative half plus 1 is positive half, all over positive half plus a constant of integration. But this can be rewritten as this, it can be rewritten as 2 u power half plus c, and this is of course 2 square root of u plus c. But we said that u should be 2s squared plus 1, so we have 2 square root of 2s squared plus 1, of course, plus a constant of integration. So this is our solution to this particular problem. Very, very simple. The last one is going to be our last problem is going to be the integral of sine power 5 x dx. This right here, I'll give it to you as a Christmas bonus. Try it out. When you get it, wherever you see me on campus or wherever, you can tag me and I'll give you some bonus, right? So this right here, I will provide the final answer to you, then you work it out for me gently. So this right here, when you work it and work it so nicely, you have 2 cos cube x all on 3 minus cos s plus a constant of integration. So this right here, I'll give it to you as a bonus Christmas or Christmas bonus. Try it out and get it done. Thank you very much for watching. I really appreciate your time. Please don't forget to press on the notification bell and share my link to others for everybody to enjoy my content. Don't forget that I'm going to give you the next techniques in integration, and that is going to be the integration by parts. You know, the integration by parts, I'm going to show you 2 ways of dealing with it. We have the tabular approach and we have the formula approach, and it's going to be so easy. So thank you. Bye.